Hi class, we are approaching the end of chapter 5 and then looking at our schedule, we will do today, like we have double block today, and then we'll do lesson 8 and we're omitting lesson 9. The reason is lesson 9 is basically same as lesson 8, is application, and then lesson 8 we use graphical approach. Once you get the equation, you graph it and then you can look for the answer. And then lesson 9 is application with algebraic approach. So you're supposed to just solve it rather than graphing it. But you are allowed to use graphic calculator, so we'll just do lesson 8 today. And then if you have time, you can also do lesson 10. You can start the practice test. Okay, the test will be next week. So just get it ready, and then when I come back, we can ask question. All right, let's look at our notes. For lesson 8, quadratic function equation, application. So this is why we study quadratic function, because there's many application. And then you can put it in a graphic calculator, and then you can find the maximum and minimum values. Usually those vertex, max or min, have specific purpose when you solve a problem. And these are the key what you type in the graphic calculator to find the maximum or minimum. So second function trace, this will be the calculate features in the calculator, and then you can look for either maximum or minimum. You specify the window left and right, and then the calculator, and then you say guess, the calculator will give you the answer. Okay, so let's look at some example. So example number 1. This lesson is not very long, it's quite short. So the first example, they give you the equation. Okay. The second example, you need to figure out the equation yourself. So example number 1, the height in meters above the ground of a projectile at any time after launch is defined by this function. All right, so what are the two variables? Time against height. So when you throw something, all right, so it says a projectile, so it's a physics application questions. And then as the time goes by, the height of the thing you throw will change. So if you plot this in your graphic calculator, you see the following. First, you will see the initial height of 3. And then, like, it will go something like that and then come down. So this will be your graph. Like, of course, there are other parts to it, but then we're interested in the y-intercept, interested in the x-intercept, we're interested in the maximum point. How high does it reach? After you put this in your graphic calculator, the important thing is you need to adjust your window so that you see the proper part of the graph. You need to keep adjusting your y until your y max is up to 150. Like the bottom could be just to say 0, so this is your y, and then your x is 0 to maybe about 15. All right, so this is your x, this is your y. This way you will see the proper window this way. So go to window, change your x max, x min, y max, y min to the following values, and you will see this. Now sketch the relevant part of the parabola, so when you throw something, it will go up and then hit the ground. Find the height of the projectile 3 seconds after the launch, which means you trace 3. Okay, so hit the trace button and then put 3. And then you find out the height is 111. Like your graphic calculator will show a point somewhere there, will show 3111. At 3 seconds, remember the x-axis is time, the height of the projectile is 111. Okay? Find the maximum height reached by the projectile, so which means the vertex. So use your second function trace, which become the calculate function, and then you want to find max, and then you define the window, and then they will tell you the maximum point. They will tell you it's 6147. So which one is the height? Well, 6t is the time, and height is 147. So asking for the height, the answer is 147. what time will this maximum height be reached? The answer will be 6. Okay, so the PQ is a vertex. It has two values. One is the time, one is the height. Make sure you answer the question correctly. What is the height of the projectile at the launch, which means the initial value, right? Which means your y-intercept. So it is your y-intercept, right? So the answer is the height is 3. It starts at the height of 3. Determine when the projectile hit the ground, which means now you find the x-intercept. So using a graphic calculator, you will do second function trace, and then you look for zeros, all right? And then you'll find out this point. They will give you roughly 12.10. Okay, so the time when it's hit the ground, the time is 12.1. So this is application question. You graph it, you interpret the meaning of various points. So this point is 0, 3. Okay, I'll show you all the significant points. So this point is not a significant point. They just ask you what happened, what's the height after 3 seconds. So you just find that point. But the other points are significant points. Okay, so now we are moving to next example and also the last example. Now example number 2, they don't give you an equation and you need to figure out the equation. So this is the most difficult part for this lesson, is to understand how do you determine the equation from a word problem. Okay, so let's try. Last season, a struggling hockey club has only 7,200 season ticket holder. Okay, you highlight, you will like circle all the number. The owner of the club has decided to raise the price for the new season to generate more revenue. Okay, so they have so many season ticket holder. They want to raise the price so that they have more revenue. Okay, how do you connect revenue, price, and number of ticket holders? Right, you multiply them. The existing cost is 1,400. If you raise the price, what happened to the number of ticket holder? Will it go up or go down? When things are more expensive, less people will buy it. So when you raise the price, the less people will buy it. But will it still generate higher revenue? Okay, we will see. And then it says here, they find out for every $25 increase in price, about 100 season ticket will not renew. The holder will not renew their season tickets. Okay, so this is the price. This is the number of tickets, and this is the revenue. So what's the relationship? Price times quantity equal to revenue. Okay, so when you read a word problem, you need to figure out the relationship between all the terms in the question. So price times number of tickets holder is the revenue. So the price start with 1,400. If you times 7,200, that's your revenue. Now, for every $25 increase, so you can make a table for yourself to help yourself to see what's going on with all this number. All right. So if you multiply these two numbers together, you have 10 million. Now, if you increase $25, so let me add $25 here. All right. And then the question say it will have 100 people less. So minus 100. Okay, why don't I write 7,100? I'll show you in a minute. Now, in that case, will they make more money or less? Because there's less people buying it, but now the ticket prices are more expensive. You put it in your calculator, you find out, oh, they are making more money. Okay, so it's good to raise the price because they will make more money. And if you raise another $25, so let's say you raise $25 twice, all right, and then you would decrease 100 people twice. This is multiplying. Okay, so now the ticket price is 1,450 and the number of people buying the tickets is 7,000. And then once again, you find out, oh, the revenue is still going up. Okay, so it's a good idea to raise. So when is the final, what is the number of $25 increase from the price so that they can get the largest revenue? Okay, so looking at this pattern, you can see the 1 and 2 and the next one will be 3 and so on. So the variable, the things that is changing is the numbers here, and the rest of them do not change. So my revenue is 1400 plus 25x. Okay, x is the number of $25 increase. So again, you look at this, what is the variable? Like here, 1400 and 25 are not variable. They are in the equation. But the next one is 1400 plus 3 times 25. Next one is times 4 plus 4 times 25. Next one will be plus 5 times 25. So the variable is this number here. I replace it with x. And then same for this one. The variable is the 2 here. So I replace it with an x. So this is my formula. Okay, so this is my formula. And what kind of formula is this? This is a quadratic formula. And if you plot this graph in your calculator, you will see something like that. And then for this window, you need to change your window so big such that the y will be let's say 12 million. Okay, and then for the x, maybe you put 20 here. Okay, and then you see such graph. And then you use the following to. So when you plot this graph, you will have the following. Your graph will be something like that. All right. And then you find out the maximum. You want to find out how can they generate the maximum revenue? You find out the maximum point is right there, is 8, and then 10240000. So you need a very big y window. So I'm not sure if graph is like that or the graph is like that. But anyway, there's a maximum point there. Okay, so there's a maximum point there, which is what you want to find out. So when you run a business, you want to get a maximum revenue. So they find out if they what does 8 stand for? What does x stand for here? Okay, so look at this question. X here stand for the number of 25 increase. Okay, so you want to increase $25 8 times, which means how much? You increase it $200. And then what is your y? Well, if you look here, your y is your r, so it's your revenue. So x is the number of times you increase, and y is your revenue, will be this much. Right? So I will answer the following question. Okay, write an expression. I already did. Determine the price of the pack of the season ticket will generate the maximum revenue. See the maximum point. So the answer is 1400 plus 8 times $25. So the ticket price should move to 1600. How many season holder would there be if this plan was implemented? Okay, well, initially there are 7,200, but now you take away 8 times 100. For every $25 increase, there will be 100 people less. So now there are only 6,400 people who buy the season ticket. But then you get more revenue. How much more revenue will be generated if the plan was implemented? So the new revenue will be this much. All right. And then you minus the original revenue, which is this much. Then the answer is, well, how much did you get more? So the answer is 160. You get $160,000 more. So okay, so the hockey organization will go ahead with this plan. Okay, so once again, hopefully you understand this example. Okay, so for this example, it's harder because you need to come up with an equation yourself. Okay, so the equation once again is revenue is